The heart of the process is the solar charge controller. It's connected to the panel, which is this. There's the panel power coming in. It drives the panel to fill up this battery, and then the load goes to this thing, which is my fake load generator. It just heats up at any kind of wattage that you want. But I also, from the energy that I get from the panel, I have this shunt, which I can measure the current, which is measured by this Raspberry Pi. And the Raspberry Pi can also control this actuator. So it measures the current, and then it controls the actuator, which moves the reflector. There's a couple bus bars that shares the battery's voltage. And this breadboard is to control my relay. So I have a relay for the relay, and this is temporary. So the reason I have the breadboard is because of these two transistors. They act as the relays that amplify the 5 volts that come out of this Pi. They're always on. The 5 volt is always on. That's the problem. The one that's controllable through software is 3 volts. So I turn on the 3 volts on and off to toggle these transistors, which then turn on the 5 volt, and the 5 volt will turn on and off to control the 5 volt relays. I really like these relays. Unfortunately, they didn't have them in 3 volt configuration, so that's why I have the extra transistors. Hi, so this is my first video, so welcome to the solar mining channel. And I built this tracker for solar, and I'm gonna title this the Sunset Catcher, because it only has a reflector on one side that is more effective at catching the sunset. Imagine if I had a reflector on here as well, then it would be also catching the sunrise. I got this idea from Tech Ingredients. This is the YouTube channel of probably one of my favorite YouTube channels right now. This guy is pretty well versed in materials and building stuff. So I highly recommend it, and that's where I got the idea for Reflector. I also later found there was a Reflector video of another guy that I really like. It's called DIY Solar. He's really good at batteries and different solar charge controllers. So and of course solar panels. That's where I learned a lot as well. And his video was more kind of skeptical on the reflectors, but it's a great perspective also to have. So as you can see, there's some gains that can be made from this reflector. And the way it works is it will sense the current, how much is being output from the panel, and it will move the robotic arm. So every time it moves it, it just tries left and then it tries right. It's a trial and error approach, and it's always kind of looking for that balance by testing what the actual physics, and not just physics but real reality is of the system. And it just tries left, and if it gets a better current, then it just keeps going left. And if it's getting worse current, then it reverses, tries to go right. Not just current, it's actually looking at power, so current times voltage. But yeah, that's how it's able to track sun. And as you see, I have also occasional full scans where I just look at all the positions and see what happens there. And that's pretty much it. That's how this thing works, and it's all coded up in the Raspberry Pi, as I already gonna show in the beginning of the video all the parts. And there will be more parts of these videos too. So this is just the first one, and I have a lot of raw footage of how I built this thing. And I actually want to try really awesome other things with it and some new things. So I can cover a lot of topics, and I do take requests. So please comment in the comment section, say which topics you're more interested in, and I'll go into those first. And I can cover anything from how the actuator is connected, I can talk a little bit about the battery and the solar charge controller and the MPPT algorithm, what's going on inside there. Although that area of expertise I would leave more to Will from DIY Solar. He is really good at that stuff, and I'm a beginner at most of these things. I can go into programming, networking, kind of Linux stuff. That's what's in the Raspberry Pi. The Raspberry Pi has a lot of moving parts to it, so we can go into how to set it up, how to connect to it, how to upload software to Raspberry Pi, how to edit text inside of it, and how do you edit text in Linux so you can code and execute your programs. How do you execute so that, like execute, I mean to run, just run the code that you wrote. So you could just run it right there when you're logged in, or you can open up a screen session. I can show those. I like using those because in a screen session you can just start your program and log out and have this completely off the grid system. And I log back into it at the end of the day and it's still running and it shows me all the output. We can talk about the relays. These are my really nice relays that I really like, and how the relays work, what are the bad relays or good relays. There's lots of things, topics. Well, yeah, here I got like the material and fabrication. That would be on, for example, the reflector, how to build this. And I would leave that, of course, to Tech Ingredients. He's the expert on materials, but we can of course expand and discuss different things. Then what about, I can even go into things like source control if you're interested in maintaining your code and having different versions of it and tracking changes, and of course graphing. That graph that you saw, I have it on a little device that just on my desk that I can watch the graphs. Yeah, but there's another topic that is I haven't tried yet, but I'm really excited about, is you might have noticed that on the graph it's doing weird things. It's kind of moving left and right, and that the whole left-right axes is all messed up, to be honest. It doesn't tell you where my intention was to show you where this reflector is at any given time. It's pretty good at telling you the y-axis, which is the wattage, how much energy, because we got good current sensing. That's the other thing I can actually go into and discuss how this current sensor works with this shunt. But that's the y-axis. But on the x-axis, everything is floating, and it's wrong because you saw that the panel was all the way here, but on the graph it kind of trailed to the left, I think, that way, and that's because when it moves left and right, it's not symmetrical. There's some skews going on. Like the robotic arm will only push out a certain amount for the amount of time that I turn on the power, but if you turn it on in reverse, it will actually not travel the same distance. And what I'm really excited about is to try to actually get an accurate measurement of where this thing is. That way my charts can be perfect and I can actually move it. As I have an idea how to make it move only a certain number of degrees every time, and that way it will be more uniform. It's not necessary if this idea doesn't work. It's basically involving a inclinometer that measures the incline. If it doesn't work, it's fine. I have the hill climbing algorithm working just perfectly fine. It tracks the sun. We got the full scans. So anyways, I'll see you on the next one.